In the last section in Chapter 4, we're going to talk about parallel lines and triangles. So, just to start out here, through a point not on a line, there's one and only one line parallel to the given line. This is going to kind of matter for two theorems that we're going to talk about today. So let's say we have line L and some point not on that line P. There's only one line that I could draw that would be parallel. So from here, that leads us into the triangle angle sum theorem. We'll prove this in class tomorrow. What the triangle angle sum theorem says is that the sum of the measures of all the angles in any triangle, no matter what triangle that you draw, is always going to add up to 180 degrees. So let's say I have just some random triangle ABC. The measure of angle A plus the measure of angle B plus the measure of angle C will always equal 180, no matter what kind of triangle it is. And we could use that information to solve for like an algebraic equation. So in diagram number 1 here, I want to find the measures of angle X, Y, and Z, which might seem kind of intimidating right now, but we're going to use that new theorem and break it down and solve for my variables from there. I'm going to start by solving for X, because I could look at that triangle highlighted and see that I have two of the angles, I only have one missing one. The one on the right, I have Y and Z, I have too many unknowns. How I'm going to set this up? 59 plus 43 plus X equals 180. On the same side, I just add them together like terms. So I have 102 plus X equals 180. Get the X by itself by subtracting 102 on both sides. And I found that angle X equals 78 degrees. So I'm a third of the way done. Next, looking at this diagram, I can see here that I could solve for Y because 78 and Y are a linear pair. They make a straight line. What I mean by linear pair is that they add up to 180. So 78 plus Y equals 180. Subtract 78 from both sides. I get that Y equals 102. Now, all I have left to find is angle Z, and now in that triangle, I have two of the angles, I only have one unknown, so I can figure out what that is. So here I could set it up by going 102 plus 49 plus Z equals 180, combine like terms on the same side, subtract 151 to get Z by itself, and I get that Z equals 29 degrees, and finally, I'm done. Well, we're going to talk about one more theorem today, but some vocab to lead into this. Looking at this diagram here, angle 1 would be considered an exterior angle. Easy way to remember is that it's on the outside of the triangle. It's formed like if you extended a side length and you made an angle that way. Angle 2 and angle 3 would be considered remote interior angles, or you could really just think of them as interior angles. They're the angles that are on the inside of the triangle. That's going to lead us to our last theorem in this chapter, which is the triangle exterior angle theorem. What that says is that the measure of each exterior angle of a triangle equals the sum of the measures of the two interior angles. So in this diagram here, angle 1 is always going to be equal to angle 2 plus angle 3. Let's use that to solve two equations. So what is the measure of angle 1 in diagram A? I see that angle 1 is the exterior angle, so angle 1 would equal the two interior ones added together. So angle 1 equals 80 plus 18, which is 98, and I'm done. In this next diagram, I want to find the measure of angle 2. Same sort of setup, but like our unknown is at a different spot of the equation. I see here that angle 2 is one of the interior angles. So the exterior angle, 124, equals 59 plus angle 2. Subtract 59 on both sides. I would see that the measure of angle 2 would have to equal 65 degrees. So notice a pattern here that none of the problems that we're going to be actually solving are too difficult in terms of the algebra. If you know the theorem and you know how to set up the problem, the algebra is going to be easy from there. It's really just knowing these formulas or knowing kind of these theorems to know how to set them up.